I'm Johannes, and I'm not doing game development full-time right now. So I used to do that a couple of years ago, and right now I'm a web developer by trade. And in my spare time, I still do game development, and I still participate a lot in game jams. So that's pretty much where most of my experience now will come from. I'm also a freelance software engineer at TopTal. So for this talk, there are a couple of things I want to address. And one of the things I want to go into is demystifying game development as a whole, because I feel like sometimes it's maybe something that you can't really grasp, or you know maybe how to develop games, but how does it really work, or where to start, and which options are there. So that's definitely something I want to show. And I also want to go into some typical game development patterns in general, something that you come across when you start developing games. And then I'm gonna show how to implement those specific patterns in React. Let's talk about the landscape of game development. Like when you say, okay, I want to develop a game right now, you have different options available. And while there's Unity, definitely the one of the big ones, there's Unreal, there's the CryEngine, and there are like millions others as well. So, okay, not sure what to choose, really. In JavaScript, we have Phaser, Impact, and millions others. Okay, so why exactly should we then choose React, maybe? First rule of game jams, which are like, think of them as hackathons for games. So you get together, and within 24 hours or 48 hours, you by yourself or in a team develop a game to a specific theme or just for fun. And since that's what I usually participate in, there's like this rule where it says use the tools you're most familiar with, which is, for me, React. So this also applies to game development by itself as an implication, but I feel this is the thing that I followed the most. So when I did development in jQuery, most of my games that I did on the side were developed with jQuery. So it feels just natural to go now into the React route. Okay, and then when I got into React, there was like a talk at F8 2014 by Pete Hunt, which was like, and there was a specific slide which I found very interesting, which said React is like Doom 3. So we had like different aspects of Doom 3, and then it was being compared to React. So logically, my spidey sense was tingling, and I was saying, okay, so if React is really like Doom 3, can we develop games with it? And so then I want to take apart an example from Phaser, one of the game engines I mentioned earlier. I actually, unfortunately, it doesn't quite fit with the link. It's one of the examples that I found on their page, and I just want to take a look at it for a moment. So we have like a game that we're setting up. We're saying, okay, it's a Phaser game. We're putting in the width, the height, like which backend it's going to use, which DOM element, and then we're defining some events like preloading, creating, update, rendering. Okay, so we are putting in an arrow, then we're creating like something with a background, and then we're putting it on the screen, then we're updating something, and then we're rendering something. Okay, lots of things that we may not feel familiar with, but there are also lots of things we may already feel familiar with. So I kind of want to take this and transform it into a React code. So, okay, we have React, and then instead of having the arrow being updated on each update function in the phaser example, so we're making it as an internal state for the component. And then inside of our React render component, we're pretty much just rendering. So it's still very similar in the sense that we have something to render. We have some logic, like the phaser update logic, for example, lives in our render component. And we have some lifecycle events, like, for example, this preload that we have, or this create function in phaser. It still lives in our React component as their lifecycle methods. So it's still kind of familiar. And I wanted to expand on that. But before we go into more specific examples, I want to take a step back and go into how a game itself works. So I like to make a distinction of event-based games, which are that the game progresses with events that are being done by the user. So otherwise the game stands still. This is pretty much like, think of a point-and-click adventure, for example, or a visual novel, or turn-based games. So only if I, as a user, interact with something, the game progresses on. It doesn't really mean that everything else stands still. We still have animations, for example, on the screen, but the whole game progression is only happening with user events. I'm pretty sure you can't hear the sound right in the back. I'm very sorry about it. So what I want to present right now is a game I made with some friends at the Global Game Jam this year, 2016. And it's made with React, of course. And it's a text adventure kind of game, like text adventure, visual novel, not sure which category it directly fits in. And the idea is, so we are a teacher and we time traveled, and we have to do several challenges that are going on. So in this example, we have like a dialogue and then a telltale kind of dialogue system. So you have different answers, but you can choose to not answer and then something happens. Or like, usually you die, which is like the case here. But this is like the kind of example for an event-based game. If I don't do anything, well, the game itself relies on those options for the dialogue. Okay, the next category I like to describe is game loop-based games. So instead of just being just a game progressing when the user interacts, the game progresses on every frame, which is typically at 60 frames a second. So in game development in general, or like game engines in general, usually achieve this by completely re-rendering everything on every frame. And the typical example would be like more action-based games like jump and runs, or your first-person shooters, etc. Another game engine game I made, which does that so in this game, this is like a kind of populous kind of sandbox game. So you place different things on the screen and the villagers move there and they should collect them, which is kind of buggy in this example, but you could see how the distinction is from event-based games. Okay, so now that we talked about how games work in general, let's go into some techniques that we have in game development in general and see how we can transform them into React code. Okay, so we talked about the game loop-based games. Game loop is pretty much the first thing. We kind of want to execute some actions every frame. So simply put, we could do that with a set interval and then just say, okay, let's re-render everything. But I mean, set interval is kind of not where we want to be. So in a production code, we would usually have something like request animation frames. And that's actually like one of my game loops that I have in my games, in my game jam games usually. So it's pretty much just we have a subscriber which just pushes some callbacks onto an array. And then when we start the game loop, we just iterate through all of these subscribers and then call this function pretty much on every request animation frame. Okay, so how can we do that with React? So React re-renders everything for us on every prop and state change. And we kind of don't want to force any specific updates then. We just want to force every state or prop update at every frame, if we need to, of course. So the typical example for that would be to have like something animating on the screen. So this is like a little character I made a couple of years ago. I scaled it up so it can be, it's clearer to see. And we have like this speed right here. So right now it's at 100 milliseconds, and we can actually, now it's moving only at a second, and now it's moving really fast. Okay, so the next kind of techniques that most game engines, most traditional game engines employ is dirty rectangle checking. So we are redrawing everything on each frame, pretty much. Let's take an example. So we have something on the screen. There's a villager on the screen. This villager is moving down, and we're kind of wasting a bit because we're re-rendering everything, but only this specific region is changing. So in traditional game development, we actually have some kind of code that checks for those rectangles where a change actually happens and only re-renders those specifics. But we don't need it in React because Virtual DOM and the next example is the entity component pattern. We know that composition over inheritance is really cool, and that's pretty much the same way in game development as well. So I like to use this example of an enemy in a game. So I have like a pirate ship. This in game development, we would refer to this pirate ship as an entity, or like the ship, depending on how granular we want that to be. We could like say, okay, we have a ship, and then a pirate ship is a specific entity that we are composing from those base objects. And then we have specific behaviors or attributes, like how many cannonballs this ship has, what's in storage, or like how much crew does it have, how fast can it move. And those in game development are usually referred to a component, to being as a array component. So then we could attach those components to entities. We could also attach entities to entities and components to components. So in React, everything is a component there. And I made a small example that I'm going to show. So I actually made a ship, and well, I made two ships. So here I have a component called black flag, which turns this ship into a pirate ship. And if I remove it, it's a normal ship. Let's put it back in. Okay. And I also can move my ships around if I want to. So what I want to do is kind of display like the health of both ships. So to do that, I made another component. And then I'm going to say health bar. And for the other one as well, health bar. Now we have two health bars. So I kind of want the pirate ship to be a bit damaged though. Something like that. Yeah, maybe a bit more. Okay. Now I kind of want to attack the pirate ship with my normal ship. So first thing we need is a cannonball. Okay, there it is. Okay, let's put some X and Y values in. 20, yeah, something like that. Let's just move it a bit. All right, a bit more than that. Okay. And eventually I'll find the correct position. Okay, now it has hit the ship. Kind of. To display that it has hit the ship, it's completely... okay, something went wrong with the health bar, but the ship got hit. Okay, so now actually we just need to put in a game loop and some more logic, and our game is finished because we have a ship which could actually shoot cannonballs and hit other ships. So this is pretty much like the idea that how we can implement something like that in React. Okay, so the next thing we have is a scene graph. This refers to having entities in a tree structure. I'm not sure how many of you are familiar with Flash, for example, but the Flash API, they had like this sprites, they were called, which could attach themselves to other sprites and to the stage. So Flash pretty much had their own tree structure as well. And that is actually what we also have in React. So that's kind of nice. And we also have this in a declarative fashion. So it's a bit nicer than just than not being able to see that. Okay, so the next thing that I want to talk about is managing your scenes. Think of it as we have like a game set up. We have a main menu, we have different levels, and we want to be able to switch from one scene to another. And in its easiest form, we would have a component where we just have a state of the current scene. And then we go inside of the render of this component, we would just say, okay, depending on the current scene, we're just putting in the other scenes. I mean, that's kind of nice, but as soon as we have more than a couple of scenes to manage, this would get kind of hard. So we would probably have some more general purpose solution for that, which is we still have a current scene, and then we are putting in different scenes through the props, and then just taking the scene from the scene object and then just displaying it. We're also passing in a function, so we can actually switch to another scene from this specific scene. So in a way, it's kind of familiar to how React Native's navigator works, or to how the React router works, but just without having being able to pop back or pop forward in the stack. Okay, so how this works is in an example. I pretty much set something up. So imagine this would be a main menu. And now we can switch to level 1, and then the other scene would be displayed, and we can go back to the main menu. So it's pretty simple. Okay, so just a short summary. I haven't hit all of the game development topics that are there, of course. I just wanted to give a short overview of some specific game development techniques that are around in classical game development and game engines. And so I would say in general, it's like React is of course not a game engine, and it's still a bit easier, I feel like, if well, so the thing is, if we compare React to a game engine like Unity, of course there's things missing, like Unity does collision management for us, physics, and those kinds of things. But React, I feel right now, if we were to use it for game development, it's like being able to tinker with it a bit more, being a bit more low level. And for me personally, this is kind of great. And I really like setting up games in React. So there's one game I want to show you super quickly, which goes into my next point. And so this is another game I made for another game jam. And the idea pretty much is that I am a vampire and want every day pretty much villagers come in and try to get me out of my castles, and I have to put in some traps and some defenses. And I also have to manage my blood source and those kinds of things. So I could build more defenses, and I have different quests, and every day something would happen. Right now, nothing happened. So what I want to go into is, could we maybe use React Native for game development? We have this thing, learn once, write everywhere in React Native, which to me comes in because we want to use native controls. We want to have a look and feel for each platform that feels like this app is native, and use the things that are available for this platform. So in game development, I feel we don't really have that because we write our own UI. We write our own UI elements. They don't have to look native. They have to look like they're part of the game. And I don't think we really care about the native look and feel too much at that point, because it should be part of the game and not part of the platform. And so my bold statement coming from that is, if we were to use React Native for game development, we could actually achieve something close to 100% code reuse across platforms. All right, that's it. I'm Frosty on Twitter and on GitHub. On GitHub, it's without the underscore.